In this video, we're going to look at what's called the law of sines. And the law of sines is going to actually let us use our sine function to help us solve a triangle. And in this case, we notice here we have a triangle, and it's not a right triangle. So if we have angle A, angle B, and angle C. And then if we label the sides, the side opposite of angle A, we'll call that little a, opposite of angle B is little b, and opposite of angle C is little c. So here, the key idea of the law of sines is that we can solve for the angles and the sides of this triangle even though it does not contain a right angle. And the formula that we're going to use is side A over the sine of angle A, which is equal to side B over the sine of angle B, or we could set it equal to side C over the sine of angle C. So what this means is we could pair any two of these and set them equal to each other. And what we're going to notice, if we were to take these two, we now have four parts: side A, side B, and angle B. As long as we know three of these pieces, we can solve for the other missing piece. Or again, we could group these two together and solve, as long as we have three of the pieces here, we can solve for the missing piece. Or we could even take this one and set it equal to this one, and we can solve for whatever piece is missing. Now, of course, we could set this up the other way. We could flip it around and write it as sine of A over A equals sine of B over B, or we could write it sine of C over C. So either way we can write this depending on how you want to memorize it. All right, so in order to use the law of sines, like I said before, we have to know three pieces. And I want to kind of describe what we're going to have here. We can use this law of sines if we have what is classified as angle, angle, side. And what I mean by that is if you have a triangle and if you know two angles that are next to each other and then the very next side. So here we end up with what's called angle, angle, side. So if we have these two consecutive angles and then the next side, we can use the law of sines. Also, if we have angle, side, angle. Okay, and what that means is if we have an angle, the very next side, and the very next angle, we can use the law of sines to solve the rest of the triangle. So again, here we have an angle, a side, and an angle. And the other possibility is if we have angle, and I'm going to label this one a little bit different here because this one's going to be kind of important, angle, side, side. And I write it this way because this is the one that tends to be a pain in the angle, side, side. In your book, they're going to call it side, side, angle, but I like to refer to it as angle, side, side because this way you're going to remember when you have a triangle and you have an angle and then the next two sides. So if you have an angle and then the next two sides, this angle, side, side is the one that's going to be a little tricky. And we'll look at that a little bit later on in another video. All right, so what I want to focus on for this video is I want to look at how we can use possibly the angle, angle, side or the angle, side, angle to solve our triangle. So let's look at an example here of how we can use this law of sines. For example, if you're given a problem that angle A is equal to, let's say, 120 degrees, and then we know that angle B is equal to 45 degrees, and little c, which means its side C, is equal to 16. So if we label this out, we know, and I'll just draw a little triangle here. I want to point out here that we have angle A, angle B, and C. So then we have angle A, angle B, and we know side C. So what we have here is, as far as I'll label this as little b here. This would be little a. So we have angle, side, angle. So this triangle that we have, given two angles in the side and the middle, this is an angle, side, angle. So to solve this, we have the two angles on one side. We want to find the other two sides in the missing angle. So I always recommend is to draw a sketch of what's represented, and it doesn't have to be to scale, and realize a lot of times when you see these triangles drawn, they're not going to be necessarily drawn to scale. So here we have A, B, and C. We know that angle A is 120 degrees. And for an example here, clearly this is not 120 degrees. And if I want to make this a little more accurate, I guess I could draw this where angle A is actually bigger than 90 degrees. So we could draw it something like this where we have A, B, and C. So this here would be a 120 degree angle. B is a 45 degree angle. And then C, which is side C, is equal to 16. That's opposite of angle C, so that means this here would be equal to 16. So now we want to solve for the rest of the sides and the other missing angle. Well, first of all, we can solve for angle C because we know that all three sides of three angles of a triangle must add up to 180 degrees. So we can simply take 180 degrees and subtract away the 120 degrees and the 45 degrees. And if we do that, and if you need to, you can go to your calculator, you'd have 180, 180 minus 45 minus 120, and we would certainly get 15. So therefore, angle C is equal to 15 degrees. All right, so then what we have left is we are left with finding side A, which is opposite of angle A. And if we look at the formula here, if we're looking for A, then we could use little a here over the sine of angle A. So that's what we're going to do. We're going to take little a, side A, over the sine of angle A, which is 120 degrees. And we're going to set that equal to, and at this point, we could choose either one. We could choose B over sine of B or C over sine of C. So we need to figure out which one do we have. Well, if we look, this is side B, so we don't know what side B is. So it looks like we're going to have to use angle C, which we found was 15 degrees, and then side C, which is down here, we were told it was 16. So therefore, we're going to take the 16. Okay, we've got to put the side over the sine of the 15 degrees. And that's how simple this is for the law of sines. Notice here, again, we have 1, 2, 3, 4 parts to this problem. And as long as we have 3 of them, we can solve for the missing piece. So in this case, we can simply solve for side A. Now to do that, we need to get A by itself. So that means we need to get the sine of 120 off of the bottom. So because we're dividing, we want to cancel that out. So we could simply just multiply by the sine of 120 degrees on both sides. And if we do that, that's going to cancel on the left. So we're left with A is equal to, and this is where we could easily go to the calculator to type this in, the 16 over sine of 15 degrees multiplied by the sine of 120 degrees. Now, when you go to your calculator, make sure that you go to the mode and make sure that you're in degree mode, because now we're working with degrees, so we need to change this to degree mode. And then we can certainly just go and type in 16 divided by the sine of 15. 16 divided by the sine of 15. And if you want to here, you could just simply hit enter. and leave this in the calculator, okay? Leave that there. And then what do we need to do? We need to multiply that by this sine of 120 degrees. So we would just simply hit times, and that pulls down the last answer, the sine of 120 degrees. And we end up with 53 point, and we'll go to 2 decimal places, 53.54. So this side is 53.54. Okay, now all we have left is to solve for side B. Now you'll notice here that we can do exactly the same thing. So if we're looking for side B, we would take little b over the sine of angle B, which is 45 degrees, okay? And then we can set that equal to, well, we could use the same thing we did before. Over here with just the previous one here, we can use this again. It's going to still be equal to the 16 over the sine of 15. So that'd be 16 over the sine of 15 degrees. Now, one thing I will point out is we could have used, instead of the 16 over sine of 15, we could have used what we just found, this piece here, which is 53.54 over the sine of 120. Now, the problem with doing that is you want to typically use what's given to you in the problem. Because we had to find this side here, if we made a mistake on finding side A, then that means that when we go down here to find side B, then we know that's also going to be incorrect. So a lot of times it's better to use more of the information that is given to you when possible. So now again, here to solve for this, we need to get the sine of 45 off the bottom. So we could certainly just multiply both sides of the equation by the sine of 45 degrees. And once we do that, we'll be left with b is equal to 16 over the sine of 15. So we go back to the calculator. 16 divided by the sine of 15. And we could certainly hit enter. And then we once again need to multiply that by the sine of our 45 degree angle. Whoops. Times the sine of 45. And we get 43.71. So at this point, we have now solved the entire triangle. Okay, and this example here, once again, was using the idea that if you're given an angle, side angle, we're given two angles in the side that's in between. And up here, this is the example we just looked at right here. And if you were given two angles and then the side, you would solve this type of setup just like we did before. So it's going to be very similar. You just have to figure out what pairing that you want to use. Do you want to take these two equal to each other? Do we want to take these two equal to each other? Or do we want to set these two equal? And again, that's going to determine what's given in the problem. Do you have side A, angle A, and side B? And then you could certainly solve for angle B. So that's going to all depend on what's given to you in the problem. Okay, so hopefully you feel a little bit comfortable with using the law of sines, and you can work out the practice problems following the video.